In problem 16, we're being asked to write the expression as the logarithm of a single number. So you're using your properties, and anytime you're going backwards with your properties, if there are numbers in front of logarithms like you're seeing here, the first thing you're going to do is put them back as powers. So notice the 4 times the log of x becomes the log of x to the 4th. 5 times the log of y becomes the log of y to the 5th. Leave the minus sign where it is and only put the 6 log of z as the log of z to the 6th. Now, your next step is if you have 2 logarithms, you're going to go left to right. If they are added, then you're going to multiply their 2 terms together. So notice I multiplied x to the 4th times y to the 5th. And I didn't do anything with the minus log of z to the 6th. And then in my final step, anytime you have 2 logarithms subtracted, then that means you put them back together as a fraction. And I always think of the subtraction symbol looks like a fraction bar. So that would be my final single logarithm answer. You're solving on question 17. The easiest way to do that is to change it to exponential form. So just like before, start at your base. 6 is your base, raised to a power of 4, and we say it's equal to 2x minus 4. Then it's just a simple linear equation. 6 to the power of 4 gives me 1296. If I add 4 to both sides here, then I'm up to 1300 is equal to 2x. And to get rid of the 2, I'm going to divide both sides by 2. So I end up with x is equal to 650. You're also solving on number 18. When we're solving log equations, you have to get a single log, in this case on both sides. So I'm not going to do anything on the left side since it's already a single log, but notice on the right-hand side, those 2 logarithms are being added. And as we mentioned above, anytime logarithms are being added, you're going to multiply their terms together. So I'm going to end up multiplying the y minus 2 times the 3. And then once I have a single log on both sides, like you are seeing here, so if I have a log equal a log, then basically what we can say is that their expressions must be the same. So this y plus 8 must be equal to the y minus 2 times 3. So that in turn leads me to y plus 8 equals 3y minus 6. And again, it's just a linear equation that I'm going to solve. I added 6 to both sides. Then I came back and subtracted my y. So 14 is equal to 2y. Divide both sides by 2. And I get a final answer of y is equal to 7. And you do have to visually go back and check and just make sure that when you plug these in, you're not being forced to take the log of a negative. So notice that's okay. If I go back to the previous question, the 650 is okay. But you're going to see on this next one where we're going to have something that's not okay. So at least do a visual check there. All right, so on 19, again, I have some logs, and if I have more than one, I need to combine them into a single log. So since these are added once again, I'm going to end up multiplying the x times the x plus 48. Notice this logarithm does not have a base written. Since it is spelled log, it is understood to be a base of 10. So when there is not a base written and it is spelled log, your base is 10. So starting with that base, I'm going to change it to exponential form, making my counterclockwise circle. So 2 becomes the power, and then I say it's equal to x squared plus 48 times x. Now in this case, it's led me to a quadratic. With quadratics, you want to set them equal to 0. So 10 squared is 100, and then if I actually subtract the 100 on both sides, I end up here where 0 is equal to x squared plus 48x minus 100. This will factor into x plus 50 times x minus 2, and when I set those factors individually equal to 0, I get 2 possible answers. X is negative 50, or x is positive 2. And the problem is, if you go back and you look at this original equation, you look right here at the original, when I try to plug negative 50 in to either place, here or even here, that creates you taking the log of a negative number. We can't do that, so we throw that answer out. Now, the 2 is okay, so that's why I'm going to keep the 2, because that is not forcing me to take the log of a negative number. Okay, on this last problem, we're looking for the interest on the loan. They tell us to assume 365 days in a year. So they're telling me that it is simple interest. So your simple interest formula is I equals PRT. And so in this case, P is the amount I invested, which they told me was $38,100. My rate is 5.25%, but you always have to drop the percent and move your decimal 2 places to the left. If there's a gap, fill in with a 0. So notice that's why I plugged in 0.0525. And then on time, you've got to look at it as what part of the year. So if it's 137 days, that is out of 365 days in a year. Then it's just a straight punch on your calculator. So be sure you show me how you plugged in before you get on your calculator. Then you can punch it out on your calculator to tell me, in this case, how much interest that they end up paying, which is $750.78.